So have you ever tried to add up two lists or perform any kind of mathematical operations over two lists and stuck getting an error? If yes, watch this video till the end as I will be explaining you practically what goes wrong when you perform any type of calculations on Python lists and why you should always select Numpy arrays to perform mathematical operations. In this video, I will show you how to solve the problems with the list, and we will also learn how to fetch out the hidden information from our data using Numpy. So as we know, Numpy arrays are much more efficient than Python lists. They are memory efficient, they are fast, and they allow complex calculations, whereas Python lists are great for storing and managing the data. But when it comes to mathematical operations, they fall short. But why Python lists cannot perform the same as Numpy arrays? I will answer this question in the later part of this video. But before that, let's dive deeper to understand how to fetch the hidden information in our data using few more functions that Numpy provides which Python list doesn't. So here I have already imported a Numpy and created an array named ARR1. If you want to know more about Numpy and how to create the arrays, please watch the video attached in the end. So if I run it and show you the ARR1, it is a 2D array with 3 1D arrays inside it. Now let's fetch out some hidden information from this arrays, like the minimum element, the maximum element, standard deviation, mean, variance, etc. So first let's find the minimum element in this array. I will write np.min and pass my ARR1. And we can see the minimum element in this array is 1. But what if I want to know the minimum element from each of these 1D arrays? So I will pass a parameter here access is equal to 0, which will give us the minimum element from each of the columns. If I run it, I get 1, 2, 3, as 1 is the smallest element in this column, 2 in this column and 3 in this column. Now if I do it, access is equal to 1 and run it, I get the minimum element row wise, which is 1, 4 and 7. Similarly, we can find the maximum element. I will write np.max, pass my ARR1, I get the maximum element, that is 9. And if I want it row wise, I will pass access is equal to 1 to get the maximum element row wise, that is 3, 6 and 9. And if I want to get the maximum element column wise, I will just change this 1 to 0 and I will get the maximum element column wise. Now let's check the mean of this array. I will write np.mean and I will pass ARR1 and the mean turns out to be 5. Let's check the median, np.median and I will pass ARR1. Let's check the variance. It's np.var. It comes out to be 6.66. And let's check the standard deviation, that is np.std. ARR1. It turns out to be 2.58. And if you want to know more about these statistical concepts like mean, median, standard deviation, variance, do check the video attached at the end. As we saw, Numpy is really easy to use and it also helps us find the hidden information in our array by using few functions. Now is the time where I will answer you why you should use Numpy over lists in case of performing mathematical operations on our data. So let's first see what happens when we try to use mathematical operations over two lists. So as you can see on the screen, I have created two lists, L1 and L2. Now if I add these both, I expect an output to be 5, 7 and 9. So let's check it out. If I print L1 plus L2 and run it, I don't get the expected output. Instead, I get the concatenation of these lists. Let's try subtracting these lists. I will write L1 minus L2 and it throws me an error. If I try multiplying both of these lists, L1 into L2, it again throws me an error, which means we cannot do mathematical operations over lists. So what is the solution to this? Now this is where Numpy comes in to the rescue. Let's see how Numpy helps us overcome this problem. So here first I will convert these lists into Numpy arrays and store it into two different arrays. So let's say our ARR1 is equal to np.array L1. Here we are converting the list 1 into a Numpy array and storing it into R1. Similarly, we will do for the list 2. I will write numpy.array L2 and store it into R2. And now if I perform ARRAY1 plus ARRAY2 and run it, I get the expected output, that is 5, 7 and 9, which we didn't get here in the list. Now if I try to subtract ARRAY1 minus ARRAY2, it doesn't throw me an error and gives me the output. If I try to multiply ARRAY1 into ARRAY2, it again doesn't throw me an error and gives me the expected output, that is 4, 10 and 18, which we needed right here using the lists. Similarly, you can perform other mathematical operation over these arrays and Numpy will give you your expected results. Now we know why Python list falls short in handling mathematical operations and how Numpy comes to the rescue with its exceptional array processing capabilities. Whether you are into data analysis, scientific computing or machine learning, Numpy is a must-have tool in your Python toolkit. If you want to know the true power of lists, check on the video to the left, and want to clear out the fundamentals of Numpy, watch the video to the right. And if you want to know more about the statistical terms like mean, median and mode, click on the video that is right at the center and I will see you right there. Till then, keep learning and thanks for watching.